Hello guys, welcome back to the channel for another Kafka video. Today's video is about Kafka and how we can achieve exactly once messaging in Kafka. It's an advanced topic, but don't worry about it. We are going to break it down to simple tasks. There are two ways you can go about this according to the documentation. You either include a unique identifier when the producer sends the messages. It includes a unique identifier, and then you deduplicate the data based on this identifier on the consumer side. The second way to do that is to save the offsets externally in a database, especially when you use a database to store transactions and you cannot afford to lose any data, like when you are working in a bank. The important part here is to commit the data and the offset in the database in one transaction. So if the transaction goes wrong, nothing will be written in the database, nor the offset or the transaction. But you will still have the last successful committed offset in your database, and then the consumer can start again from that specific offset. In other words, we need to achieve two things, right? No data loss, we should not lose any messages, and no duplicates. We shouldn't process the same thing again and again. It's not an easy implementation, so bear with me. Let's see first what configuration we need to have from the producer's side. The first thing that we need to take into consideration is to set acknowledgement to all. What is acknowledgement? When the producer sends data to the brokers, then the brokers can send back an acknowledgement saying that they received a message. If we set acknowledgement to none, it would be fire and forget. We are not waiting for the brokers to send an acknowledgement back to the producer. So it could we could have data loss. The same thing could happen with less chances when we set acknowledgement to one, because the producer sends data to the leader broker, and when the leader broker receives those those messages, it sends back an acknowledgement to the producer saying, yeah, we received the message. But if we set acknowledgement to all instead of one, we are going to wait for all the replicas from all the other brokers to reply to the producer to send this acknowledgement saying that they received the data, and make sure that we don't lose any data. So there is no data loss. This is very important because we don't want to lose any data. The second thing is to create an idempotent producer. What is an idempotent producer? Is when the producer ensures that no duplicates are introduced due to unexpected rise. For example, if you see here, the producer sends the data, the broker commits the data, sends the acknowledgement back. This is fine, but then on the second case, the producer sends the data and the acknowledgement was never received on the producer side due to a network error. And then the producer sends the same data again because it didn't receive the acknowledgement, so the broker has duplicates now. And how can we handle this case? So each producer gets assigned a producer ID, PID, and then it includes this PID on every message plus an increasing sequence. So there is a combination of PID and a monotonically increasing sequence. And then what happens is on the broker side, we track the largest combination of PID and sequence number. And if a lower sequence number is received, then it is discarded. So we need to set the idempotence to true. Now, bear in mind, this is only on Confluent Kafka and not in Python Kafka. The only thing we can do in Python Kafka is to set acknowledgements to all, right? And this is what we are going to do in our demo. In our example, we are not going with the first approach to add a unique identifier on the producer side and then deduplicate those data on the consumer side based on this identifier. Instead, we are going to use MySQL to save the last committed offset, and if things go wrong, then we are going to fetch the last offset and seek that specific offset in Kafka Python and using my rebalance listener. You will see that in a. This is the producer, nothing fancy. We went through this code in our previous videos. What we do here is define a topic name, define the number of partitions, and the replication factor. In this example, we are using only one Kafka broker to keep things simple. What the code does here is check for the topics. If the topic doesn't exist, then we create a new topic using the admin client here, and we define the number of partitions and the replication factor, and then we create a topic, right? And then we create a Kafka producer, we define the bootstrap servers, and we provide the serializer for the value. We are not going to provide any key, so the messages will be distributed on the partition based on a round robin fashion. And here we create a random amount and we pass the value, this value, the amount as a value here, and the producer sends the data to this topic. And we sleep for a few seconds. Let me increase that here to, let's say 10 seconds to make things easier now when we run the code. Now let's move to the consumer. Although let me switch to MySQL and see what we did on the database, which is important. The first table here that we created, it's called demo data, and we have an ID which is a sequence and an amount. Here we store the transaction. As you can tell, this is just the amount. It's not complicated transaction, but let's say we have data for a transaction. We store the amount here, and here this is the offset table, which is the important part. And we have two columns, the latest offset and the latest partition. So let me insert two values here in these two records in this offset table, and let's select everything from the table. As you can see, we have two records with the latest offset that would be 0 for both partitions. Remember that we are going to create two partitions. So that's why I have two records, one for partition 0 and one record for partition 1, and for each partition we are going to store the latest offset. These are all the tables that we are going to use for this demo. Very simple. Of course, things could become a lot more complex and you need to have a different architecture, but for the demo I think it does work for the purpose that we want it. Back to our Python code, and this is the consumer. That's the most important part here. It's a bit difficult, so bear with me. Let's start from the first step. In the main function, we have to instantiate a connect database object that I have created here a class which connects to the database in the init function, and then I have defined a few functions here, one simple function to execute an update, for example, and one function to select the first record of the first row to return the latest offset. Remember that we created a simple table on the database to save and fetch the latest offsets for each partition, and this is what we do here. We execute the SQL that we are going to provide and then return the offset. This is to get the latest offset. And then we have one function to commit the data. This is important because we want to insert the data, the amount, into the table, and then also save the offset and then commit. We don't want to insert the data, to insert the amount and commit, and then something happens and we don't save the right offset to the database. So we want everything to be committed in one transaction. And the last one is to close the connection with the database and the cursor, etc., etc. So let's we have this database object here that we are going to use in our code. We provide the topic name, the bootstrap server, the consumer, and we set the offset reset to earliest. We are going to read the data from the beginning, the value deserializer, the group ID, and here the important part is to set enable auto commit to false, because we don't want to commit to the Kafka broker. We are going to store the offset to our database and use that offset in case something happens and we want to start the consumer from that specific offset. So we don't commit here, right? And the next thing we need to do is actually create an offset object that we pass the database connection. Of course, there are plenty of ways to do that. I just used this this architecture here. You could say we have the class offsets, and here in the init function we define a dictionary that we are going to store the offset for each partition. So for partition 0 and partition 1, which is the latest offset, every time that we insert the offset into the database. And the database instance here, we have the populate function that will pass the partition in the offset. And here, this is the offset dictionary that we defined up here. And for each partition, we assign the offset. Then we have the insert balance, and this is where we insert into the demo data table the amount, right? So we insert the amount into this demo table that we created. We pass the amount here, and then we have the store offsets that we pass the partition, and actually for this we set the latest offset that we get from the dictionary where the latest partition is the partition that we passed. And here, as you can see, that's why we need to use a dictionary here to save the latest offset for each partition. And then in the if we have the partition, we can get the latest offset from that dictionary and save the data into the database. And then we can commit the data. So we will see about that in a bit. And then we have the rewind offset, we pass the partition, and we select the latest offset from the offset table where the partition is that. So in case of we have a network error, things go wrong, what we have to do is fetch the latest offset for that partition and restart the consumer from that specific offset. And again, we pass into the dictionary, we pass the latest offset, and we return the latest offset. And then we have the remove partition from the dictionary, from the offset dictionary that we defined here. So we are going to use that as well. The next step is actually we go back to our main function, the consumer rebalance listener. Now here we have defined this this class here that inherits from the Kafka.consumer rebalance listener. Now, if we click on that, you can see this is the consumer rebalance listener interface that we are going to implement with our own code. If you scroll down, you will see there are two functions here that don't do anything. We have to implement them. So the onPartitions revoked, which says this method will be called before a rebalance operation starts and after the consumer stops fetching data. It is recommended that offsets should be committed in this callback to either Kafka or a custom offset store to prevent duplicate data. This method is only called before rebalances. It's not called prior to Kafka's consumer close. And we have to implement this method here and this method down here, the onPartitions assignment. And as it says, this method will be called after an offset reassignment completes and before the consumer starts fetching data. It is guaranteed that all processes in the consumer group will execute their onPartitions revoked callback before any instance executes its onPartitions assignment. Let's go back to our consumer. And here, as you can see, we have the init function that we pass the consumer and the offset object that we created here. And we also implement those two functions onPartition revoked. That's the important part here. They're all so when things go wrong, we have to store the latest offset to the database. for each topic partition in revoked, and here is that we implement, this method here. It's a custom implementation. So for each topic partition in the revoked here, the argument that we pass, then we store the offset. So if we click on the store offsets, actually if we go into the offset, remember the store offset function, we pass the partition and stores the latest offset. And let's go back to our offset class, and where you see store the offsets, then we execute an update and we get the latest offset from the dictionary. That's why we want the dictionary here. That's why we define the dictionary, that we store the latest offsets, because then we only have the partitions. Down here we can only get the topic partitions, we don't have the offset, right? So that's why here we have defined a dictionary that we save the latest offset for each partition. So when we pass the partition, then we also have the latest offset, and we execute an update in the database that we update the latest offset for this exact partition. And the second thing we do on this method on partitions revoked is to remove the partition from the dictionary, right? We stored the latest offset for this partition, then we don't need it anymore in our dictionary, so we remove it from the dictionary. We remove this record for this partition from our dictionary. And then on partitions assigned, again, what we want here is to fetch the latest offset from the database and give it to the consumer and start from that specific offset. How can we do that? We can, of course, fetch the latest offset for this partition, and that's why, again, we have only the topic partition. So that's why we use the rewind offset function that we defined here, which is a simple select from the offset table where the partition is the partition that we passed, and then we assign this offset to this dictionary that we store the partitions and the offsets, and we return the latest offset. And this is what we do here. And I use our consumer to seek this specific offset. So we pass the topic partition and the latest offset, and the consumer will start reading the data from that specific offset. Now let's scroll down again and see what we do here. So we have this listener. We define the offsets object. We define the consumer listener with our implementation to store the offset to the database, and then fetch the latest offset when it's necessary and start reading from that specific offset onwards. And then the consumer has to subscribe to this topic, and on the listener argument we pass the listener. The next thing we do is actually start reading messages from the Kafka broker when we use our consumer. Here we print the value, the topic, the partition, the offset, and then we process the record. So if we go into this method here, we pass the offset object, and what we have to do, like, think in very simple terms. The first thing is to insert the amount into the database. So in the insert balance method that we have implemented here, we execute the query, right? We insert the data into our demo data table. We insert the amount, but as you can see, we did not commit here. The next thing, because if things go wrong, we don't want to commit this amount to the database. We want to commit this amount only when we have stored the offset. This is very important, right? And that's why when we, the second thing is to populate, and here just we populate the dictionary with the latest offset, right? But the next thing is actually store the offset to the database, passing the partition. And if we go here in the store offsets method, we update the table and we save the latest offset for that partition. But here, as you can see, we commit the data. This is very important because we don't want to commit the amount if we haven't uh, saved the latest offset in the database, right? In one transaction, we need to save both. And that's why the commit data is when we store the offsets and not when we store the amount. In one transaction, we pass the amount and the offset. Perfect. And that's the whole thing, right? That's pretty much this is it. Now let's start our producer and the consumer and make a demo. Let's start our producer, and here, as you can see, created a topic, but we said it set a random amount. Let's start our consumer as well, and as you can see here, the first we have the rebalance listener automatically triggered, and it called the revoke. We don't have anything here, but then on we assign a partition, right? So we have two partitions for this topic, apostles topic, and partition is 0, and then we have a second partition, and it was assigned to this consumer. Both partitions were assigned to this consumer. As you can see, we have the latest offset here, the value, etc., etc. Let's see in the database. We have, let's select from the demo data, and here we are able to see the amounts, and in the offset table we are able to see the latest offset for each partition, right? It's pretty cool if you think about it. So again, here you can see the data from the producer and the consumer receiving the data for each partition and the latest offset for each partition. This is our second consumer, so let me run this and see what happens. Come on. Again, as you can see, now one partition 1, was assigned to the second consumer, right? And here on the first consumer, you can see that upon revoked, we got the latest offset from the database, and we started reading data from there. And here, as you can see now, we have one consumer consuming data from partition 1 and one consumer consuming data from partition 0. The latest offset is 7, right? 92, partition 0. Okay, so I had to speed up reduce the sleep time to speed up the process a little bit. As you can see, one consumer is consuming from partition 1 only and one from partition 0. Let's go back into the code and actually see what happens. So here, what you see is when we started the second consumer, we got assigned upon on partitions assignment. This function was called, and it got the latest offset from that from partition 1 to start the second consumer, and we use the seek function to get to start reading from the latest offset. Now this is going to happen. So if you, let's see the data again in the offset table, as you can see, for partition 0 we are in the 50 offset, and for partition 1 we are on 46 offset. Now here, let's stop one consumer, and the other consumer will pick up the latest offset from the database for the partition that it was assigned to the consumer that we are going to stop. So let's stop one consumer and see what happens. Yep, I stopped one, and here, as we expect, let me stop the second consumer so we don't lose these logs here. as you can see, it says these partitions, this topic partition was revoked, and now the first consumer, got assigned 2 topics. And you can see it read the latest offset from the database for partition 0 and partition 1. And this is the whole thing here, that this is the method that we want to ensure that we store the offset externally when we commit the amount as well. And if things go wrong, we will start picking up the data from that point onwards using the consumer rebalance listener. There is one caveat I would like to mention about this seek method. And here, as you can see, what it says is we manually specify the fetch offset for a topic partition. Okay, so it overrides the fetch offsets that the consumer will use on the next poll. Now here is the caveat. So if this API is invoked for the same partition more than once, the latest offset will be used on the next poll. So note that you may lose data if this API is arbitrarily used in the middle of consumption to reset the fetch offsets. And this is important when, for example, you have only one partition. You are going to lose data because the consumer will start from the offset that we specified in this seek function, but then as you can see, when it's invoked for the same partition more than once, then it starts reading data from the latest offset. So it will jump from this offset that you specified to the latest offset, and you are going to lose data. This is a bit tricky when you have one partition, right? The next thing that you can do, the next best thing that you can do, is actually commit the offset manually to the Kafka broker. Let me switch to VS Code. So let's create a new topic with one partition. And here on the consumer side, as you can see, I have a few lines commented out. Let's uncomment that. And here is how we can manually commit offsets to the Kafka broker. So we can again insert the data into our database if we want, but it's not necessary to use this rewind offset when we assign partitions, because automatically we have committed the offset to the Kafka broker, so it will pick it up from where it was left. Let's uncomment this stuff here. And here as well, actually, we can still insert the database. It doesn't really matter here right now. So we are going to start committing the offset to the broker manually. And let's demo that and see what we get. Okay, so let's start the producer again for this new topic and sense data, right? So let's start the consumer again. As you can see, it read from the beginning, right? 93, 52. Let's stop the consumer. As you can see, the latest value is 54, right? And here, again, we have new data coming in. Now, if I run the consumer again, it will pick up from the latest offset. That would be offset number 8, because when we commit the latest offset +1, because the consumer will have to start again from the next offset. So it will read the data from offset 7 till the latest one, and not from the beginning. As you can see here, let me stop it again because the logs are plenty. It started reading data again from offset 8, 9, 10, 11, not from the beginning. Now, if you run the previous code, now that we have one partition only, if you run the previous code, it will go from offset 8 and then it will jump to the latest offset. So it will skip all those data and it will jump to the current offset. And this is where there is, this limitation using external, because you are using the seek functionality on the consumer side and it has this limitation. So be aware of that. I don't think it will be a huge issue, in a full-scale implementation when you have plenty of partitions and that kind of stuff. Just bear in mind that you can also commit the offset manually to the Kafka broker, and this is the second safest option. The last thing I want to mention again is when we commit the offsets, right? We commit the current offset +1 because the consumer will start consuming for the next offset. We don't want to consume again from the same offset and have duplicates, and the same we do that the same here. As you can see, when we populate our dictionary, we save the offsets to the database. This is it for today, guys. I hope you enjoyed the video and you learned something new. I know it's a lot to take in one go. There's a lot to absorb here, but that's why I'm going to upload the code on GitHub in case you want to play around yourself. And I tried my best to give you a good example of how to use the consumer rebalance listener. Please click the like button, leave a comment and subscribe to the channel, and I will see you in the next one. Thank you.